All right, without further ado, our presenter today, Cameron Presley, is going to be presenting on preventing bugs with better types, an intro to type-driven design. And Cameron is based on Charlotte, North Carolina. Cameron has over 15 years of experience working with both startups and large enterprises to design, build, and implement solutions in various domains like fintech, healthcare, education, and agtech. In addition, he maintains a blog at blog.thesoftwarementor.com, where he writes about leadership, functional programming, and process improvements. And I, skipped the most important part, I think, Cameron. Cameron is the owner of Small Batch Software Solutions. That's at smallbatchsolutions.io. He's a speaker and a Microsoft MVP in developer technologies. Outside of technology, Cameron can be found hanging out with his family, playing board games, improving his woodworking skills in the shed, and reading various books. Thank you very much, Cameron, for coming and presenting to us today.
Yeah, thanks for the intro. I really appreciate that. You'll actually get to see some of that subpar woodworking in about 2 seconds. So,
fantastic.
But yeah, so good evening, everyone. I'm excited to be here. This is actually my second time being at this user group, and I really love coming out here. It's not too far from the house. It's a great group, and I love coming out to communities, right? Like coming back in person. As we all kind of realize, COVID's been an interesting ride, especially for user groups. So anytime there's user groups in my local area, I will do everything I can to support them. As already mentioned, my name is Cameron Presley. I am the owner of Small Batch Software Solutions. What do? We put projects back on track. That's what we do. So if you've ever been working on a project and you're like, oh boy, this thing just keeps going into bigger and bigger piles of mud, and it'd be really great if someone could just put that back on track. Absolutely come chat with me. And it's okay if your boss or someone you know is in this room, you don't really limit that, that's okay. There's a secret QR code you can use later. As mentioned, I'm a Microsoft MVP in developer technologies. I've been in that program for 9 years now. All that means is that I really enjoy giving back to the community. So I started publicly speaking about a decade ago. Actually, yeah, it has been just a little bit ago. Crap. That's a lot to think about. So yeah, and so as such, I've been kind of recognized for some of my work in that field. And as mentioned, I'm also an amateur woodworker. This is the first project I ever built. It is a workbench. It sucks. The only good thing about it is on wheels and it's somewhat level. Why do I show you this really awful workbench? The reason I show this to you is because this is one of the first things I ever built. When you learn something new, guess what? It's going to suck. Even if you have a mentor helping you out, even if that mentor is maybe circuits instead of a person who's done it before. But it's okay, you need to embrace that, embrace the suck, if you will, and get used to it. So everything you're going to see tonight is already live. If you trust me, you can scan that QR code and it'll take you to the website that has the slide deck, articles, code samples, everything. If you don't trust me, probably because you're a security engineer by trade, you can go to blog.softwarementor.com/presentations and you'll find similar information. So what we're going to be talking about tonight is this idea of type-driven development. Now, I'm going to take a guess that if I'm at a .NET user group, we're pretty comfortable using statically typed languages, right? So this is so you know what compilation errors are. You know you've done dumb stuff like trying to pass a number into a function that wants a string, vice versa, right? We intuitively get that. But what's type-driven development? It's this idea and concept from other languages where we can define our types in such a way that we actually prevent developers from doing the bad things. There is a really great blog post about this called Falling into the Pit of Success. And the entire idea behind it is that if you make it easy to do the right thing, guess what? Your developers will do the right thing. And if you want to make them if you don't want them to do bad things, make it really hard, if not straight up impossible. In fact, Jeff Atwood, in that same blog post, talks about this. If you're not familiar with Jeff Atwood, I guarantee you are familiar with at least 2 things that he's worked on / owned. This really cool website that was popular about 6 years ago called Stack Overflow. That was kind of his shtick. And yeah, he was kind of involved with Discord. So if you're familiar with that service, he has hands in both of those. Suffice to say, he kind of knows what he's doing from the tech scene. So when you're looking at other communities, the functional programming community at large, you'll hear this thing called making a legal state unrepresentable. Anybody in the room is familiar with this idea of domain-driven design, DDD? Right, so you've got your domain models, they have certain naming, and you try to wire them up in a certain way. It's kind of really making sure the same principle. And I want to I can give you some technical mumbo jumbo, but let's actually look at a little bit of code. So let's say I've got this cool little function called print color. Give it a string and it prints it to the screen. Relatively straightforward, nothing crazy. So I can pass in the string orange and it works. It'll print orange to the screen. I can print blue. And then I can tell it to print platypus. Now, I know Pantone has a lot of colors, so many colors. But I don't think they've got one like platypus blue, right? I don't think that's a real color. The problem is this code will absolutely work, right? Because my types say, oh, just have a string. Cool. What can be strings? Anything can be strings. For those of you who've been in .NET for a while, do you remember when you didn't have link to SQL or Unity Framework and you got to throw raw SQL over the wire? Wasn't that fun? And you didn't know when it broke until you ran the app. And you got a really helpful, hey, your query sucked. And you're like, great. Can you tell me where? No, I'm not going to tell you that. It's this idea, right? So stringly typed things are pretty much the bane of my existence. And most of the times I work with clients on their code bases, I find stuff like this all over the place. So what can we do? And before I show you some possible solutions, I want to ask you all, right? You all, everybody in this room, I'm going to take a guess has been developing for at least a couple months, if not years, if not 5 years plus, if not decades. So if I wanted to limit what could go into this function, what's something that comes to mind?
Ready, enum.
Enums, yeah, sure, we can do that. That's awesome. So we can do that. We can make a public enum of color, throw some colors in there. We can even be really smart about it and give an unknown. So if we actually don't know what the color is, right, we have a reasonable default. And now we've made our print color a little bit more type safe, right? Because now we're saying it can only take in things that we call colors. So this doesn't seem like a huge thing, but I can't tell you how much easier it is when I talk to business people, when I show them these types. Hey, in this system, we say that a transaction can only be one of these 4 types. Does that make sense? And they go, yes. Or actually, no, you can have like a reverse withdrawal. And you're like, oh, I'm sorry, what is that? And then you now realize you just violated a whole new context. And, you know, Eric Evans is crying. So, right, and to kind of show some examples, right, by passing strings, it's not happy. And I actually get a nice, helpful compiler message that says, yo, strings aren't colors. How about that? So that's neat. And that's how we would fix it. Nothing too crazy there. So let's take a look at something a little bit more nefarious. Units, right? So let's say I've got these 2 functions. I've got one that says if you give me kilometers, I'll convert it to miles. And if you give me miles, I'll convert it to kilometers. So that code works. It's not maybe as many decimal places as it should be, but it'll work. And this is all well and good. And now I can start doing stuff like this, right? So I've got some code that says, well, 5K in miles is convert kilometers to miles. Here's this 5, and you would get like 3.1 miles or so. And then I could do the same thing where I'm going to convert. I say it's 10 miles in kilometers, and I'm saying convert kilometers to miles. That's not right. I think that's wrong, right? 5K is that many miles, but I flip-flopped. That's the problem. I've actually messed up my units here, right? I should have, instead of calling convert kilometers to miles, I should have said convert miles to kilometers. But I had nothing to help me out with that. I screwed up, right? Insert any type of engineering confusion here. Would someone use metric instead of imperial units? Insert any, and this can actually get worse, right? I'm picking on like units of measure. How about latitude and longitude? Those are numbers. You flip those around, you're going to be a notion most likely, right? It would be nice if I could have prevented this somehow, or if I could straight up prevent it, make it really annoying.
I'd like to know how those 2 conversions, the matrix to imperial, and what you just said, how many rockets they've blown up. I know they're responsible for at least 2 major incidents.
So I'm going to take a small detour real quick to actually answer that. This problem is so like well known that in F# language, they actually create a thing called unit of measure, a type for that. If you take a look at it, and it allows you to define like, oh, 1 kilometer is this many meters, so on and so forth, right? So you define that. And F# language will prevent you from mixing them. It literally won't compile as a built-in language feature. So just that's my little brief detour. So if you're bored Friday evening looking for something to do, it measures in F#. So that's the problem, right? We're passing the wrong stuff here. So we're going to fix that. So we can do a little bit better, right? I can create enum because I'm only dealing with 2 types of measurements, right? I've got kilometers and I've got miles. I got nothing else. And I'm going to use a record type. Now, are we familiar with what records are or not so much in C#? I know records are kind of like a relatively new thing. You can think of records like objects, except they do equality correctly. So instead of doing by memory, they do it by value. And they give you some other advantages. For example, if I define a class, this should be like 10 lines longer because with the get sets and everything else, don't have to here.
Are they reference or value?
They are by value.
So they're structs under the hood? No. Okay.
I'm gonna waffle my hand.
But I should think of them as value types.
You should think of them as value types.
Okay.
For my domain-driven friends, these are value objects. You can absolutely think about it that way. But some cool things about records is that they are equality by value, not by reference, which is awesome. This is also the same thing of giving this a public get private set, like read only. So I didn't have to define all that other syntactical sugar. So I've got this thing called a measurement, and what you do is you tell me a length and you give me what unit is that length in, right? So if I was going to use this measurement, you might get something like 10 miles or something. But here's where my conversion function looks like now, right? Where you give me a measurement of like whatever I got, like 10 miles, and now you tell me what you want it to go to, right? So you have to give me that new unit, whether it's kilometers or miles. So I'm being a little bit more clear here that says, all right, well, if I'm going from kilometers and I want to go to miles, call this function, and I have to be very clear what unit, right? I'm actually saying that I'm going to miles. And same thing here, saying kilometers. So I'm being very clear, it's this number, this unit. So now when I take a look at this code, and I actually run it, I get the right answer. And that's because instead of making the developer read similarly named functions that look really similar to each other, and I'm hoping that you are not having a bad day and you didn't actually flip-flop something like we did originally, this is much more clear. I'm converting 5 kilometers to miles. I'm converting 10 miles to kilometers. It reads like English. It reads the way I would even talk to someone about this. And this wasn't that big of a lift and shift, right? Not too bad. So I mentioned all of that because it's cool that we're talking about our units of measure. It's cool to talk about colors, but let's talk about something a little bit more meaty, shall we? So when I learned how to do functional programming, there's kind of like this well-worn path you travel. And one of the first exercises you get into is actually modeling card games. The reason being is that card games is a good stretch of domain modeling logic. There's plenty of complexity that you'd like to go into. In fact, I have a whole talk where I kind of go over my journey. And tonight we're actually going to be modeling certain parts of Blackjack. And the reason why I choose Blackjack is because this is a game where all the rules are known and there are no inconsistencies. The reason being is because you play this in casinos, right? You can bet money. I can assure you the casinos do not want you to play a game where the rules are vague or undecided, or you could be like, well, technically I won that one. Nope, it's very concrete, black and white, right? Like I said, we're not going to model everything in Blackjack because I only have so much time, but we will model some common workflows and show you some interesting ways to think about things. So if you've never played Blackjack before, I'm just going to go over a really high level what things are going on, right? So you can play Blackjack with a standard deck of cards. If you go to a casino, they usually have 10 or 20 decks in the shoe, but it doesn't matter here. Standard deck of playing cards. And when we talk about a card, they have this thing called a rank and suit. Right, so if I have an ace of spades, for example, that ace is what's called the rank, and that spades is what's called the suit of the card. That's how that nomenclature works. That domain terminology, one could argue. So when I'm doing a domain modeling breakdown, what I like to do is I identify the nouns. This isn't a functional programming thing. I actually learned this from OO, right? And for those who may have some experience being imperative, then going to OO, you may remember the old trick where your nouns were your types and your verbs were your methods. Guess what? That trick kind of works out really well here in functional. So I'm just going to identify some nouns, and the nouns I came up with based on this is what? What nouns do we have in this 2-sentence description? Besides a lot of questions about what in the heck we're going to be doing.
Rank and suit.
Yeah, rank and suit. Those sound like nouns, and those are specific to this problem, right? For example, if I take that rank and go into the world of chess, it actually talks about columns on the board. It's a very domain-specific term for playing cards. Suit, same thing. Card is also a noun, right? That's a very specific thing in this context of the game.
Say deck too.
Bingo, right? Because and so to kind of back up, if I was in construction, deck would mean something different, right? Usually some type of structure attached to a home that allows you to go outside. And cards, it depends. If I'm in the library system, a library card means something very different than a playing card. For example, after you play Blackjack with normal playing cards in a casino, they usually destroy the decks afterwards. You would never destroy a library card after using it one time, right? It's again about a context of terminology. So yeah, we've got some nouns here. So what I like to do is I'm going to draw a happy little picture. So I've got these nouns, right? I've got deck, card, rank, and suit. And here's where it gets interesting. When I'm thinking about my types, they're usually related to one another somehow, some way. It's pretty rare for a type just kind of float in space and not interact with anything. Right? It's usually being poked, prodded, done something. So what are those relationships? How can we look for those? So what I like to listen for is a certain phrase called has-a. Either has-a or is-a. If I hear that, that helps me out, right? So we can say that deck is one or more cards, and cards have a rank, they have a suit. So you can just using just the description of the problem, you can kind of figure out what some of these relationships are. Now, how to model them? No clue. Haven't gotten that far yet, but I know we have to relate these somehow. Also, at this point, I've not written a lick of code, right? This is actually just a GraphViz module, but this could be a mermaid diagram, this could be a markdown, could be anything, which means you can talk to the business and make sure you've got your context in mind before you start writing code. I know you're really excited to write the code, but you gotta get this part first. So the cool thing about this is that now that I have like which way my arrows are going, I actually know how to implement it. I can flip it the other way around because rank has no dependencies. Nothing depends on rank. Nothing depends on suit. And card, it depends on rank and suit. So if I have those two defined, I can define what card is, so on and so forth. In certain languages, like F#, OCaml, and ML, that's actually how they process code. They go straight top to bottom. So if I define card up here, and card has a rank, and I define rank down here, it doesn't work. So I like to think about this too, because as somebody who like thinks about projects, let's start with the zero dependencies and start building from there. So let's take a look at rank. So rank, when we think about it, it can only be one of a set number of values, right? It can only be ace through king. It can't be anything else. We learned earlier that strings are a terrible thing to model types with. So I'm just going to define an enum. And this works. This already will remove a whole structure of bugs from my code because I can't have a rank of like facet hound. I can't have a rank of chair. I'm limiting my problem space by these. And if I squint my eyes a little bit, I could give that to somebody in the business and they can read that roughly speaking. Like, oh yeah, that makes sense.
Why is 9, 10 together?
Why is, yeah, that's just me being a terrible, like,
Oh,
okay. I forgot the comma.
Like your compiler will catch that later when you try to do 9.
Yeah, I'm like, 9, 10, right? And I'm like, 19? No, that's all wrong. So I think you're the first person to catch that typo.
I thought maybe it's like, you know, combining, I don't know.
No. Though, weirdly enough, hold on to that idea. Weirdly enough. So And, just like enums before, we can say, rank.ace, and that'll work just fine, no problems. There is a small, I'll say kerfuffle with using enums though, and this is a straight limitation of language. There's nothing preventing me from typecasting any number into an enum. That will delightfully compile, that will delightfully work, that will be an absolute runtime error though when it comes time. As of right this second, there is no way to prevent this with enums in C#. Stay tuned. I'll show you some things you can do to mitigate this quite a bit, and actually a language proposal that is getting closer to being brought into the language to solve this. But yeah, unfortunately, that's the thing we gotta kind of keep an eye on. However, remember from before, make doing the right thing easy and making the wrong thing a little bit harder. This would probably stand out to me in a code review. Hey, that's weird. Why are we typecasting rank? Why are we doing that? Yeah. So I'm going to give you a new piece of terminology that's independent of functional programming, but it's this idea of I've got a type that can only be one of a finite set of things. In functional programming, we call this a sum type. And to be a little more specific, you've actually learned a new phrase called an algebraic data type, ADTs. So if you ever find yourself writing code and you're like, oh, I've got this type and it can only be one of a set number of things, it's sum type. That's 100%. You can take that to the bank. You got it. Now, how you model those in your language, it depends. You can use enums. That works great. In some languages, they have better support. So for example, in F#, this is how you would define that. You could literally just write it down as string literals. Anybody that work in TypeScript? Man, doesn't this look really familiar with what you would do? It's because that's what TypeScript does. It's sum types under the hood. Yeah, just put double quotes in around the literals, and we do this all the time in TypeScript, right? All the time. And in languages like F# and TypeScript, you actually get better compiler support because if I had messed up with the 9 and 10, it would have actually flagged, like, hey, that's not an option. But remember earlier you said, oh, maybe I was combining them. Here's how you would read this. Rank can be an ace or 2 or 3, that single bar. You would know that as the bitwise OR operator. So that's why I was kind of joking earlier, oh, it's kind of funny you mentioned combining. Not quite. But that's how I can read that.
I thought maybe you were trying to combine 10 and jacks instead of the same value.
Oh, no. No. Yes. Okay, cool. So it's interesting that you mentioned that. So let's think back to our problem domain. If I treat 10 and jack as the same concept, that means I wouldn't have 4 10s and 4 jacks in the deck. I would only have 4 10 jacks. The fact that it's the same value, cool, but that's a different part of the problem domain, which we'll get to. So, and then in F# you would do things like let ace, let rank show that. And in F# and other languages like TypeScript, I actually get a fun compilation error if I try to typecast it to 1,000. They'll argue and be like, nope, that's not a valid thing. And the compiler actually gives you the full readout, nope, here's all your stuff. Which, that's pretty cool. So the reason why I call that out is this is an actual thing that is coming to C#. So when you're bored on your Friday night looking for something to do, I know I do, you can click on the hyperlink here, but you can actually search for type union proposal, and you will see this massive write-up of them bringing this idea as a first-class citizen into C#. But you might be asking, hey, Cameron, if it's in F#, that means it's in C# because it's both interop in the .NET runtime. And the answer is yes, kind of. What F# does is it spits out code that the CLR can run, which is great. But the way it manages that so that C# is happy is not so great. Let's just say it generates a ton of classes under the hood. That means things to be less than desirable. So actually making unions first-class citizens in C# is pretty cool. But depending on how much time we have, I'll actually show you a way that you can do better pattern matching, and you don't necessarily need this. It'd be cool if we had it, but you don't necessarily need it. So I'm gonna take a pause here. Any questions? Anything that you're like, hey, that's kind of cool, or hey, that's pretty dumb?
Why would these be discriminated unions and the other ones would be sum types? Aren't they the same concept?
They are the same concept. So you remember how sometimes engineers call different things for different reasons?
Same as mathematicians, same as physicists, same, yeah.
Yeah, well, no. So algebraic data types. Okay, so you've got a math background though, right?
Yeah.
Okay, cool. So I'm going to take a side. Algebraic data types come from actual modern algebra.
Right. Yeah, yeah.
So they come from
Abstract.
category theory. So they have their own nomenclature. Computer science co-opted it, so we call things slightly different.
But it's the same concept.
It's, yeah, very much the same concept. You'll also hear the phrase tagged unions. That's another one you'll hear a lot as well.
Okay.
But suffice to say, if you, once again, hey, I'm dealing with a type that can be one of finite set of values, C#, Go, Haskell, whatever. It'll be like, yeah, here's the concept you need to know it as. Here's how you model it.
Yeah, that makes sense.
Great questions, though. Developers are awful. That's why we cannot name things to save our life. Especially when we don't talk about that. So the cool thing is we just knocked out rank. Awesome. Let's work on suit. Suit's going to look really similar because suit can only be one of four things, right? Hearts, clubs, spades, diamonds. It can't be anything else. So, ta-da, done. We've got suit. Not too bad. So now we have rank and suit defined. Now we have to go to card. Now card's interesting because card is not a finite set of values, right? If you think about it, if I've got 13 ranks in 4 suits, it's the multiplicative, right? I've got them all of those possibilities, 52. I do not want to have to write a 52 case enum. That doesn't sound great, right? And oh God, what if they add another suit? What if they add another rank? This could get, I'm going to be typing all day, or I'll just make my AI agent do it. But regardless, it's not great, right? And so this is where we're switching from sum types into modeling. Hey, I need to represent all the possible combinations. When we hear those words, we actually have something known as a product type. And even if you don't know any functional public class with a get set property, right? That models all possible ranks and suit combinations. Has to by definition, right? No tricks there. Now, typically what I like to do is I can make my stuff read only so I don't have to worry about global state being manipulated, so I can get rid of the sets. And then what I can do is just ditch that, put the second option altogether and just do the record like we were talking about from before. So cool, I've got a card. It has a rank, it has a suit. And I call this a product type because if some types are A or B or C or D, product types are A and B and C. It has to have and all of those things. So much so, in fact, that for my TypeScript engineer in the back, if you recall, you can combine 2 types together with the ampersand. That's not picked up. So we were talking about TypeScript earlier. So you sound like you were very familiar with the vertical bar. Have you seen the spot where you can take 2 types and combine them together using an ampersand? Yeah, that's a product type. You're literally ending them together. That's why I'm saying, like, you look at TypeScript and go, well, that's just too obvious. But yeah, so in F#, it would actually look something very much like this. In TypeScript, it would look suspiciously like that as well. Yeah. And then so if I want to create an ace of spades, I can just say curly braces rank equal ace, suit equal spades. Things work great, no problem. If I try to give it like additional properties like point, that won't work because card inherently doesn't have a point. And the reason why I call this out is we've got a deck of playing cards. If I play in Blackjack, they have points. If I play in Solitaire, there are no points. So I probably don't want to attach that to my domain model. Right? If I play a game of hearts, it also has points, but they're not these type of points. Right? Because, for example, queens are worth 13. Like the queen of spades specifically is worth 13 points. So some fun domain modeling things there. All right, cool. So we defined rank, we defined suit, we've defined card. So let's go to deck, right? And deck is interesting because it's not a sum type, right? There's not just a finite representation. In fact, there are as many representations of a deck as there are stars in our known universe. I would not want to write out that enum case. My hands would get tired. And it's not a product type because what would it be? Its properties, right? It has one or more cards. Technically can have 0 cards, right? Because you can run out of cards in the deck. So when this comes up, you actually have a type alias running around. So in this case, we can model deck as a list of cards, and that's an okay place to start. I will not show it here tonight because in C# it's a little bit finagly. But just because you have 2 lists of cards doesn't mean they're interchangeable. For example, in their game of Blackjack, right? Let's say I've got my deck of cards and I represent that as a list. And I've got my hand of cards. That's also a list. And let's say I write a function called draw that allows you to draw a card from a list of cards. I don't think I should be allowed to draw a card from my opponent's hand or from the dealer's hand. So yes, you can start with this, but you might find that not all representations are the same or equivalent, and you may want to do some tricks to fix that. But type alias is a great place to start, and if you need to fine tune it a little bit, you can. Actually using a sum type, weirdly enough, by using labels. So in F#, I can literally say a deck is a card list, and then there's me creating just an array of 2 cards, ace of spades, king of hearts. And then I can do some fun stuff with it, right? I can map over it, grab the rank off the cards, and then for each rank, I can actually just print it to the screen. If list.map looks weird, just pretend that said .select. And if .iter looks weird, pretend that said .for each. And now my link friends are happy.
Is list a built-in keyword for F#?
It is. So list in, I apologize for what I'm about to tell you this, because I know it's going to cause some heartburn. So F# is interesting because it has something called a sequence. Sequence is actually an IEnumerable under the hood. Lists are what you think they are. They actually are lists. And arrays do map to arrays, but not quite maybe the way you think. So, and before C# introduced the shorthand syntax for lists with the square brackets, this used to throw people off all over the place. Because anytime you saw square brackets in C#, that's an array, always an array. But with the new collection object initializer magic, that could be a list now. But I don't really want you to focus on syntax too much here. The big thing is like, oh, I can create a list of things and I can do something with those things. Because guess what? In almost any language and problem you're solving, you're dealing with a collection of stuff. So what are the collections that they use, right? In fact, there's a whole language built upon just using lists. For those who've been in the industry for a long time, you know this language is Lisp. Lisp processing language. That's kind of the joke from it. Yeah. And in fact, I actually try to help out my friends here, with my C# friends with the link. But same thing. It's just that. Well, so small aside, map is one of those terms that like every other language. Well, so map is something that every other language knows that by. No one knows it as select. That's a Microsoft Link specific thing. Same thing for each. That's a very Microsoft specific thing. Most other languages will call it either iter or iter. I'll be the other one. Maybe you might see it in like some TypeScript libraries, but no. And the reason why Microsoft calls it .select because its original intention was for linked SQL. Select is a very well-known keyword there, so that's kind of why it has that terminology. Though I do like the fact that they use where. I wish we had used where. Filter is kind of confusing, but that's a whole different talk, whole different thing. Anyway. So at this point, we actually have enough to be dangerous to start building out some rules, right? Because we've got our rank, we got our suit, we got a card, we can create a deck of playing cards, right? Because you showed us how we create one. Let's look at some fun business rules. And the first set of business rules we're going to look at is a really common scenario, which is trying to figure out these cards I have in my hand, how many points are they worth? If you're not familiar with Blackjack, the whole premise of the game, right, is that you want to get as close to 21 points as possible without going over. And you also want to beat the dealer because that's how you get paid, right? So you kind of have these two competing ideas, right? You want to get as close to 21 as possible, but if the dealer busts, that's fine. It doesn't matter what you have. So we got to figure out how many points though, right? Because that's how we calculate all this stuff. So points are based on the card's rank. And so if you have a 2 through 10, it's worth that many points. 2s are worth 2 points, 3s are worth 3 points, so on and so forth up to 10. Jack, queen, and kings are worth 10 points, always. So far, this seems pretty straightforward, but there's a small fly in the ointment. Aces. Aces can be worth 1 or 11, and the answer on when is it kind of depends. And as a software engineer, when you talk to the business and they say, it depends, that's when that shiver goes up your spine and you go, crap, now I've got to put special casing in. Also, to have repeatable code, you can't just say, compiler, figure it out. Just flip a coin. That doesn't usually work out super well. I'm going to show you how we'll figure this out. So we need to model this. So we have a new domain concept. We have this concept of points. We have this new domain thing. We got to figure out how to model it, right? So it's not a collection of things, right? Because you don't want like multiple points. That's not going to work. So you've got sum or product type. So this is the pop quiz for the room. Yeah, sum type is great because it can only be worth one specific value, right? Technically.
Except for that.
Well, but we'll see how we'll handle that though.
Okay.
But for the people who are thinking sum, what do you think your cases are? Like what are the options you're going to list in there?
Digital cases, I would say.
Ooh, but what do you do for ace? Because it's not worth one value, it's worth two different ones, right? So there's
That's
actually,
why I was hesitating with the sum.
well, so there's actually a trick here. I withheld some domain knowledge from you a little bit. So when we're talking about cards and points, there's actually a very specific term called hard versus soft. So if I'm ever dealt, let's say an ace and a 6, that is 17 points, but it's known as a soft 17 because I can always draw a card without busting. That's why it's soft. Now, if I had a king and a 7, that's a hard 17 because I have no wiggle room, I have no flexibility, right? It is what it is. So for points, I actually have 2 types. I've got one scenario called hard, and it takes an integer to be happy. The second case is I'm calling it soft, and you have to give it 2 integers for it to be happy for its constructor. Or if you're thinking like, how is this going to work? Think about it like this. Points is an abstract class. Hard inherits from it, and the hard constructor takes an integer for its input. Soft also inherits from points, and it takes 2 numbers for its constructor. For the gentleman who was talking about like tagged unions and discriminated unions, this is
There's the discriminated union.
yeah,
part.
bingo.
Yeah.
So this was the whole type. And we can actually model this in C# not too terribly bad without having new classes. Records actually work insanely well for this type of stuff.
So this has been in the back of my mind, and it doesn't apply to blackjack, but a deck of cards also can have like a wild card in there. Joker.
Yes, it could.
You could model it with like you have a deck of cards, and it can be a combination of suit and value, or it could be a joker. Okay.
Correct. If the game required that. In blackjack, we never play with a joker, but yes, it absolutely could.
Okay.
Now, the fun part is, though, remember when we were building up the deck before, and you now said like a card could be this other thing? If you've not handled that, the compiler will delightfully tell you all the ways you have failed. But that's also the power of statically typed languages, right? Like if you change the domain model, it delightfully lets you know, okay, if you're changing it, here's what's going to break. So now that I've got points, I can start doing some logic with this. So I'm going to create a function called card to points. And what it's going to do is if you give me a card, I'm going to return back some points to you. So, and that's just some highlighting there. So this match with, this is legit the pattern matching that C# got a couple of years ago. F# has had this since version 1, though, that was released a decade ago. The old joke in F# used to be that whatever F# got, C# would get it 4 years later. That was always the running joke. But what I'm going to do is I'm going to pattern match on that rank. And then I get to do some cases. So if I get my ace, I'm going to throw back that soft 1, 11. That way I know like that ace is worth one of those 2 values. I don't know yet, but it'll be one of those 2. And then 2 goes to the hard 2, 3 goes to the hard 3, so on and so forth. And then for my last sets, Jack, Queen, and King, they also just go hard 10. So I have an example of this in C#, which I can kind of like show you a little bit after, but just match case, it's the exact same thing here at this junction. In F#, because it has exhaustive pattern matching, that's why I don't have to have the default fall through at the end like I have to for a lot of other things. So that's pretty so cool. So we've got a way to go, given a card, I've got points. And this is pretty important because as a developer, if I'm thinking about how to score a hand, here's what I would do. I would take each card, figure out how many points it's worth, and just add them up. Right? That's what I would do. Well, I've got step one done. I figured out how many points each card's worth. Now I get the fun part of trying to add them. And the cool thing is, if they were just regular numbers, that's easy. That ace is a real pain in the keister though. So what can we do? Well, we are going to define some business rules here. So if we get, so I'm just going to write a basic add function that takes in 2 points and is going to return points. Okay. But I've got to do some investigation on what type of points I've been handed. So if I get 2 hard points, then I'm just going to add their values together. So think like if I got a king and a 7, I'm just going to add the 10 and 7 together, get 17, no problem. Now, if one of the cards is soft, I have to return back a soft value because it could be worth 2 things. Because if you give me an ace and a 7, that is worth either 8 points or 18. I don't know which yet. I know it's going to be worth one of those 2. And then if I get handed 2 soft points, right, because I have to go through all the combinations, there's 4 of them. So this is the case where I get an ace and an ace. You can work it out in like a truth table, but essentially what you do is you take the 2 low values, add them together, so you get 2. You never add the 2 high values together because 11 plus 11 is 22, so you bust, so you always throw that out. So you then add the high of one and the low of the other. Suffice to say, if I ever get an ace and an ace, I'm returning you back 2 and 12. That's what you're getting. So those are my business cases. Let's write this out. So I've got my function called add points. It takes in 2 points called A and B. Go return some points. Not too bad. Here's what's really cool. And C# just recently got this. I can match on both those types here. So I want to match on that A and B. And if they're hard, I can deconstruct them. I can say, cool. If A was type hard, I want the integer out there. I'm going to call that integer X. If B is hard, I want the single integer out of there, call it Y. And that's what I want to add together. I actually recently rewrote this in C# for today, and I was surprised that I actually could do this. It wasn't that long ago that I couldn't pull the syntax off at all. I had to do a lot of weird typecasting, and then if that was not null, then so that's been awesome. And then here's an example with the second card was soft, right? If A is hard, I get its integer out. But if it's soft, I can get both its integers out, call it Y and Z. And that's how I'm adding the rules together. And the next case is the exact same thing, except just flopped. Right? Same exact thing. In fact, I even use the same variable names. And then for my last one, where I've got essentially two aces being handed together, I actually don't care for this argument. I don't even know, I don't even want it. So I just throw it away, I discard it. Because it's also pattern matching, it's realized that I've done all the possible combination of points. So I'm not getting flagged any compilation errors and warnings. And this works. So I now have a way of taking 2 points, adding them together to get more points.
Isn't it the high value that you want to? Yeah, I think you're discarding the wrong one. Based off what you said in the last slide.
Let's see. Yeah, it is. Oh, man.
Because Y plus Z would be 22.
Yep, it would. Yes. Sorry, I'm having to do my own math there. Cool.
So before you go to the next slide, Cameron, so we've done this problem in like basic, where we didn't have all these fancy types, but we used something that can happen in Blackjack, where you can only have one soft card. So we use a special variable for that. Could you reduce the set, because I'm maybe jumping ahead a little bit, because your hand basically is a combination of hard and soft cards, but you can only have one soft card in there. So you reduce a hard card, a soft card to a hard card.
Not true. You can absolutely have a hand with 2 aces in it.
Right, but one of them is a one. It is, at that point, it becomes a hard card.
Correct. And that's actually what we're about to.
Right, that's
Okay.
what we used in the basic solution.
So, so as he was already talking about, we're going to get a situation where if I do all of this, I may have a situation where I've got like a soft value that's way over the limit, right? So we're going to write a function called normalize. And here's a great example. If I get ace and 9 and I sum those two together, I get 10, 20, right? Because I can treat the ace as a 1, 1 plus 9 is the 10. And then I can take the ace as 11, 11 plus 9 is 20. So I got 10 and 20. And I'm really dumb. So I decide to draw another card. And I get this king. Well, I don't have 10 anymore. That option's gone, right? I have to treat this whole thing as 20. And specifically, it's a hard 20 now. So I've got to make that differentiation. So I'm just going to write a function called normalize, right? Oh, I forgot I had this illustration. But solve 20 and 30, which doesn't make sense, has to be a hard 20. So I just wrote this small little function called normalize, take some points. And it's going to match. And if it's a soft value and y is greater than 21, it just converts it to hard for the entire points. Otherwise, cool. Just let it be whatever it is. No work needed. So with this in mind, here is our entire add points function. So here's where we calculated how many points a plus b is. Here's where we define how to normalize, and then I'm just returning the result. In F#, there's not really a return keyword. So it's whatever the last statement is in the function. So for my C# developers, that may look, actually for almost any developers, that may look weird, unless you're Python, which is cool. Great to have you here tonight.
Rust does that too, right?
I think Rust does as well. But so suffice to say that we have a way now to add 2 points together. So that's great. Now that we have these two pieces, right, we can go from card to points and we can add points. We can actually do our step. So here's the entire function. So I'm going to define what my initial state is. And my initial state is going to be, what if you tell me to calculate the score for a hand with 0 cards in it? Your score would be 0, right? Because you have no cards. And then what I'm going to do is like, I'm going to go, cool. I'm going to take cards, convert each one to points, and then I'm going to reduce all of those points together using that add function we just wrote. For my C# friends, that's the same thing as doing a select followed by an aggregate. And this will work. And the cool thing about this approach is, I'm going to geek out here for a little minute, I don't really have to write error handling, error checking, or any of that code on here for a couple of reasons. The select and link has some really cool properties to it. It doesn't throw exceptions, especially as long as you're giving a pure function, which is what we're doing. It doesn't throw exceptions. It guarantees to give you back the same length of items that you started with. So if you gave me a hand of 2 cards, you're going to get 2 points back, right? You get all that for free. And aggregate is guaranteed to work as long as you have some type of reduce function, which we do, called that add, because it takes 2 things and reduces it down to 1. As long as those properties hold, which they do, this automatically works. So if we get, let's say that your jokers, right? Let's say that we had jokers come in and jokers were, let's say they're worth 9 points, whatever. All I have to do is update my card to points logic. I don't have to touch this at all. I don't even have to come back and fuss with this method at all. It will actually just work, which is kind of nice. You can also write unit test on this if you wanted to. Wouldn't be too bad. It's pretty slick. How are we doing on time? Okay. Last thing I was going to talk about is called drawing a card. So drawing cards is interesting because how do we handle failures in our systems, right? Usually it's by chucking an exception. I don't know about you, but my IntelliSense doesn't tell me when things throw exceptions, right? I usually just get like some type hints and that's it. So, and with newer versions of C# you can at least get something on the nullable, but outside of that, there's not much. So I'm going to kind of show you a common problem that we run into is like, how do we do something where we can't, like draw, right? So we're going to try to draw a card from the deck. And I go, all right, well, I'm going to match the deck. So In F sharp, I can do this really cool pattern match that essentially says, well, if it's empty, square braces, otherwise give me the first element and then everything at the end. Think like a linked list. That's kind of what I'm doing here. And I go, all right, well, that's easy. If I've got at least one element, I'll go to the second case and I'll return you back whatever the head of the deck is and the rest. That's straightforward. If the deck's empty though, I can't give you any cards. So I've got to throw an exception. I don't have any other choice. The problem though is throwing exceptions for something that's not unexpected is a really crap experience, right? Throwing exceptions if your app is trying to connect to a database and it can't find the database, that's probably reasonable, right? Your app throwing exceptions if it can't authenticate, probably reasonable. Trying to draw from a deck that's empty, maybe not so reasonable. So we got to figure out how to handle that and to make all this work. So I think last year when I gave this talk, I kind of talked about this idea of expanding your inputs, or sorry, expanding your outputs or reducing your inputs. So the problem that we have here is that I can't always guarantee to give you a card in the rest of the deck. So I've got to denote that somehow. I can use null, but then I've got to add all this if null checks everywhere, null propagation checks and all this other stuff. So one approach that some languages use to handle this is something known as like an option type, and we'll talk a little bit about that. And this just gets even worse if you're telling me I get to draw multiple cards, right? So let's say you want me to draw like 2 cards, and then I start doing stuff like this, and I get some exception stuff. That's not great. Talked about missing values, nulls. Stuff's fun. There's even a really cool null object pattern, which essentially is where you create kind of like a fake empty object that you throw everywhere so it won't break, but then you get to figure out why everything's empty. So that's kind of fun. So in most languages, though, they have this idea of called option. In Haskell, it's called maybe. So if you ever hear maybe or option, this is the concept. So in these cases, it's a sum type where you have 2 kind of flavors. Oh, God. One flavor is, oh, this is something, and here's the value. And the other case is nothing. It's not null. It's just none. Just nothing. So like an empty class, essentially. So what I can do now is that my updated draw function, I thought I had some highlighting there, apologies. So if it's empty, I return back none. Otherwise, I wrap it sum, and it does not show up great here, so I'll throw some highlighting. But you'll see that before this is card and card list, now there's this option bit. That option's the magic. That's what's actually going to tell F sharp that, hey, you're going to need to do some better work on this. So, and here's how I've got to update the multiple drawing scenario, right? So match, if it's none, cool, we eject, right? We don't have to do any more work because I can't draw anymore, we're done. And if it works, then cool, I can draw the second card, so on and so forth. But one thing that's not great about this code, nesting. That nesting is really annoying, right? If you've worked in C#, you've seen code bases where it's like if, inside an if, and inside an if. And for my JavaScript and TypeScript developers, we used to call this callback hell, right? All the way out. Similar idea. So that's not the greatest thing in the world. So can we fix that? Well, you can. So option is actually a built-in type to F sharp. You don't have to write that code. That just exists for you to use. So the big thing to remember is if you want to take an option and then say, hey, if this works, I want you to do something else with an option, use a method called bind. And if that seems weird, think of bind as select many, right, from your link days. If I want to take a list of these things and a list of these things and shove them together, you would use select many. And then if you have a list of things and you want to convert it to a different shape, you use map, which is what we're doing here. Now, I'm not going to lie to you, this code sucks to read. This is awful, especially if you're not used to this, right? Right, because there's a whole bunch of like arrows and map and all. Blah, blah, blah. So F sharp actually gives us a much cleaner way of writing this. That's actually a lot more intuitive. They have something called expression builders. For anybody who's got a Haskell background, this is essentially monads. They've done like a cleaner syntax for that. So you put this into your code base, which, defines what find and return is, all that stuff. Doesn't really matter what this does. The thing that cares about is, here's what that new code looks like. It's doing the exact same thing from before. But the way to read this is like, okay, I'm going to return you back an option. I'm going to get my card in my new deck. And if that works, I'm going to get you the second card. And if all that works, here's the result. Much easier to read, much easier to understand. But from a functionality perspective, it's exactly what I showed you 2 slides ago. And
Is the exclamation mark on the let what's deconstructing? Okay.
bingo. So the option here is what's denoting the builder that we built. Let bang is with bind, and the return is literally the return. And these are in the docs for F# the language. So I didn't come up with the terminology. That's like part of implementing the pattern. Once again, I don't necessarily care if you understand how this code works specifically. What I really want you to care about is oh, I've got operations that are dependent upon another and one of them can fail. How can I handle that failure without having to sprinkle 20 if checks throughout my code base? You're going to need to have something like that. The one that you're all probably the most familiar with is the null propagating error. Null propagating operator, the question mark period, which allows you to do class A, question mark dot, question mark dot. That's essentially an implementation of this. The only difference is that the null propagation operator is from the class level, and this is more functions, but similar concepts, all the same.
I think Rust has the same thing with question mark. I think is the operator they use. Yeah.
Yeah. It's kind of interesting. So I've not played around a ton with Rust, but one of my fellow coworkers was, and he'd be like, Cameron, we're doing this thing and this looks dumb. And I'm like, all right, Jerome, here's what that really is. Right. But that's normal, right? You see, because Rust took concepts and inspiration from other languages. I'm going to let you know, F# didn't come up with most of the syntax stuff. In fact, it actually comes from a language called OCaml. And when I say that, it's so close to OCaml that you can take regular OCaml code, throw it in F# and it'll work. That's how much they borrowed the syntax.
Quick question about
Yeah.
that's draw multiple. Does it always draw 2 cards?
In this case, yes.
Okay, because I was thinking why don't you use a recursion? Draw multiple cards and draw
Okay.
multiple.
So
Fine.
so I have to be careful when I show people recursion, because there's people like you and me who are like, oh yeah, recursion, that's normal.
Yeah.
And then I have to remember that I've got engineers who've never seen recursion because they don't come from a comp sci background.
Okay.
Right? Because, but no. So going up in the soapbox, it would be very unwise of me to assume that everyone's got the same comp sci background, especially nowadays with modern tooling. I used to do a lot of mentoring with boot camps. They don't spend time on recursion because for the most part, it doesn't come up a ton, right? Especially if you're I remember coaching on the front end development boot camp. The only time recursive came up is when they had a JSON object that wasn't deserializing correctly. And then they're like, well, why is it talking about a recursive thing? I'm like, it's not, but let's. So you could absolutely do this as recursive, but I kind of wanted to show this cleanly.
Okay. All right.
Read directories and files. That's where I usually see it most, I think.
Yep.
Why is it a card times card list? Because the types don't seem to match.
No, so it's a card. So it's a.
I know deciphering the type signatures can always
it's
be.
okay. So I always find it easier actually going right to left.
Sure. Yeah.
Weirdly enough.
Yeah. No, it's an
So
option.
the option makes sense.
Yeah.
The card list to card list goes
That's
here.
the new deck.
Yeah. And then this is a tuple here. And because I've got square brackets, that's what's making it a list. Because in this case, I'm going to denote that it actually is 2 cards there. But I also don't know if that's just something up with the IntelliSense there.
That's what I say. The card times card would be a tuple, but card and second card are each individual cards.
Yeah, it should just be card list there. So I'm not sure why it's thinking it's a tuple, because it's not.
Okay. All right.
This is also a screenshot out of VS Code.
It could have updated a second after you took it or something. Yeah.
It's okay.
All right. Thank you. I was just like, what?
Microsoft.
I think also the type syntax is backwards from how Haskell does it with the option and the list and stuff. Doesn't like Haskell, it's like list and then the generic and
So,
type abstract
so
the
the
other way
reason, so the reason why they do that in Haskell is because
It's a
they,
function.
the piping.
Oh, okay,
So F# does the pipe to throw the thing on the left at the end of the right.
right,
Haskell prefers composition, so which is why it flips the other way.
okay.
So much so, in fact, that if you go through any Haskell tutorial, the first thing they teach you is this function called flip,
Right.
which literally flips the argument order for exactly this reason. So we covered a whole bunch of stuff tonight, right? Whole bunch of stuff. I'm not expecting you to become experts, and I definitely don't expect y'all to be like, oh man, I want to do F#. The biggest things I want you to think about, right, is how do we take a domain and break it down into models, right? This whole idea of types and how can we design our types such that we can prevent developers from doing bad stuff. I want you to think about some types and product types, right? This idea that types typically fit into, hey, I can only be one of a finite set of things versus, oh, I'm a collection of things. And then I want you to think about like, hey, how do we handle when values aren't available, right? And option being one of those scenarios. If that's all you got out of this talk, that's fantastic. I would challenge you to start looking into some of these concepts though, especially as they're coming into C#, right? Like you can do some in product types. Well, product types you can do right now, that's records. And some types I will actually show you right now what that looks like in C#. That's not too bad. But that being said, I did want to say thank you for letting me come out and hang out with y'all this evening. Once again, QR code for slides and resources if you want them. And then let's say that you want to chat with me about stuff, whether it's like working together on the project or, hey, Cameron, your presentation was awful and I want to, send you some heat. That second QR code, all that will do is it will just prompt you, like when you scan it, it'll prompt your email client to just pre-populate a to field. That's it. It doesn't have any other canvas there, but if you want to send me an email, you're more welcome to do that. Otherwise, I really do appreciate you all letting me come out tonight and hang out with you all. Love talking about this stuff and geeking out. So I really appreciate it.